Assalamualaikum warahmatullahi wabarakatuh. Today, me and my group will present our group-led assignment for subject ITT300, which involve us using Cisco Packet Tracer. Before that, we will introduce ourselves. My name is Taufiq bin Ghazali, and my teammates is Muhammad Fikri bin Muhammad Faizal and Muhammad Mikhail bin Albert.
Our network topology design. We use a star topology on both the left and right side, where all PCs are connected through a central switch. This makes the network easy to manage and to troubleshoot. On the left side, there's a DHCP server that automatically assigns IP addresses and a DNS server that translates domain name into IP addresses. On the right side, there's also another DHCP server for that network. The two networks are connected by router A and router B, allowing devices from both sides to communicate with each other. Overall, the design is very reliable, easy to expand, suitable for small office and campuses network.
Now, I will explain our addressing table. Every device on this network uses a short-threaded subnet mask. This divides the network into blocks of 16 IP addresses, giving us exactly 14 usable host addresses per segment. Routers A's FA0-1 interface at 128.0.0.1 acts as default gateway for LAN A. Routers B FA0-1 interface at 128.0.0.17 is the gateway for LAN B. Their FA0-0 interfaces handle the direct link between the two routers. In LAN A, critical servers and PCs 1 through 11 are assigned IPs ranging from 128.0.0.2 to 128.0.0.14. They all point to 128.0.0.1 to reach outside networks. In LAN B, the DHCP server sits at 128.0.0.18 and PCs 12 through 20 range from 128.0.0.20 to 128.0.0.28. The traffic routes through the 128.0.0.17 gateway. Notice the switches have no IP addresses listed. They operate at layer 2, silently forwarding traffic between the PCs and routers using MAC addresses, requiring no IP configuration for basic operation. When a PC in LAN A communicates with LAN B, it sends the data to its gateway, router A. Router A forwards it across the serial link to router B, which delivers it locally, segmented, organized, and efficient. Now, I will explain our subnetting calculation. Our subnetting calculation is actually the same for every subnet. It's just that it will be changed to the end. So now, let's break down how we divide 128.0.0.0/24 into 4 subnets. Why 4 subnets? Even though we have 3 subnets, we cannot settle for less for the calculation, so we use 4 subnets. First, our original /24 network gives us 256 total addresses. That's 2 to the power of 8, so 32 minus 24 equals 8 host bits. To create 4 subnets, we borrow 2 bits, because log 2 times 4 equals to 2. So this changes our subnet mask from /24 to /28. But following what shows, where minus 28 mask, each subnet gets 16 addresses. That's 2 to the power of 4, since we have 4 remaining host bits. Now, we're gonna go for every subnet calculation. For subnet 1, it starts at 128.0.0.0. The wildcard is 0.0.0.15, so the range runs from 128.0.0.0 to 128.0.0.15. The usable hosts are to 0.1 through 0.14. So subnet 2 begins at 128.0.0.16. That's 1 times 16. Adding the wildcard of 15 gives us 128.0.0.31 at the end. Usable host from 0.17 through 0.30. Subnet 3 starts as 128.0.0.32. There's 2 times 16. The range ends at 128.0.0.47. The usable hosts are 0.33 through 0.46. Each subnet follow this pattern, but like the subnet number -1 by 16 to find the exotic addresses, they add 15 for the broadcast addresses. Remember to subtract 2 for each subnet for the network and broadcast addresses when counting usable hosts. Now, I will explain our subnetting table. This table summarizes our 3 subnets, each using the 255.255.255.240 mask. There's a /28 CRDR notation. Subnet 1 starts at network address 128.0.0.0. It supports 14 usable hosts with IP addresses ranging from 128.0.0.1 to 128.0.0.14. The broadcast address is 128.0.0.15 and the default gateway is 128.0.0.1. This is the router edge interface. Subnet 2 begins at 128.0.0.16. It also supports 14 hosts from 128.0.0.17 to 128.0.0.30 with broadcast at 128.0.0.31. The default gateway here is 128.0.0.17. This is the router-based interface for LAN B. Subnet 3 starts at 128.0.0.32 with hosts from 128.0.0.33 to 128.0.0.46 and broadcast at 128.0.0.47. Notice there is no default gateway listed. This subnet is dedicated for the router-to-router connection itself. The link between router A and router B, since this is a point-to-point link between routers, it doesn't require a default gateway configuration. To conclude for this part, each subnet provides 16 total addresses, while the 14 are usable for hosts. We lose 1 for the network address and 1 for the broadcast address as I explained at the subnetting calculation. This efficient /28 subnetting scheme maximizes our address space while keeping network properly segmented.
Alright, starting this off with router A. Here we are checking out the routing table using show IP route command, just to make sure all our IPs are assigned correctly and the connection are good to go. Moving right along to router B, we are doing the exact same thing. We just pull up the routing table to verify that the networks are properly mapped and talking to each other. As you can see, this is the result when we ping from PC to PC in the same subnet. Now, here is what happened when we try to ping between PCs that are in completely different subnets. You can see the replies coming back without any packet loss, which prove that our routing between the different network is set up and working perfectly. Over here, we are doing a quick DHCP verification. We ping the servers and then ran an ipconfig command to show that the device successfully grabbed its IP address, subnet mask and default gateway automatically. Next up, we want to test our server connectivity. First, we are pinging the DNS and HTTP servers directly using its IP address, which is 128.0.0.3, and as you can see, we are getting successful replies. And to prove our DNS configuration is doing its job, we are pinging that exact same server again, but this time using its domain name, which is metaufi.com, and it resolved the IP and pings successfully. Finally, the moment of the truth, we open up the web browser on one of the client PCs and type in our domain. Here is our ITT group project web page loading up over the network just like it should.